So now let's welcome John, Adler, co-founder and CRO from Celestia, giving us the talk, DA 100 Days Later.
Hi, everyone. My name's John. I'm one of the co-founders of Celestia, Chief Research Officer at Celestia Labs. I mostly do protocol research, kind of manage the engineering team in terms of protocol development. Today I'm going to talk about the first 100 days, or I guess 122 days to be more specific, after the launch of Celestia, and what having scalable data availability available has kind of allowed applications and developers and stuff to do. Okay, so the Celestia blockchain launched on October 31st, 2023, which was 122 days ago, unless I'm mistaken. So this is kind of a screenshot of the block explorer where you can see the first block that was created. Since then, there have been approximately slightly under 1 million blocks that have been created, and about 4.5 gigabytes of data blobs, worth of data blobs that have been posted to Celestia. Which, if you tried to put 4.5 gigabytes of data on, let's say Ethereum call data in that amount of time, that would be extremely expensive. Okay. So what has the launch of Celestia, being the kind of first DA-centric blockchain, what kind of throughput has it kind of allowed? And of course, Celestia is the first of many. Here at the Restaking Summit, there's other, DA, I don't want to say DA blockchains, but let's say DA mechanisms being developed. One of them being EigenDA for EigenLayer, which my understanding will offer some similar throughput. You could say more, you could say less, whatever. But what's important is to compare it against what currently exists. So if you look at Ethereum call data, the kind of average throughput of Ethereum blocks is somewhere around 10 to 15 kilobytes per second, which is like dial-up speed, right? Like dial-up speed is like 56 kilobits, right? Divide that by 8. Yeah, it's in the same order of magnitude as like dial-up internet, which is not a lot, right? Celestia supports 8 megabytes per 12 seconds, which is approximately a throughput of 670 kilobytes per second. And kind of the relative difference between the two is kind of shown on this chart here, where you can see you can barely see call data. I had to increase it a little bit just so you could see the blue. Otherwise it'd be too few pixels. So kind of the launch and the availability of these highly scalable DA protocols is kind of crypto's broadband moment, right? Like the internet, when it went from dial-up to broadband, it just opened up a whole wealth of applications that you straight up couldn't do before. Things like streaming, right? Uploading videos, having social media sites where you pass pictures around, music streaming, content sharing. All of this would be, I guess, not impossible to do with dial-up, but it'd be very difficult. Okay. So the previous slide was talking about throughput, but concretely, what does throughput give you? Well, among other things, it can give you much cheaper fees. It can give you other stuff, and of course, the fees are contingent on market prices and so on. But as a general rule, it can give you substantially cheaper fees. That's why a lot of people are excited about things like EIP 4804, EigenDA, and Celestia, because they unlock a whole bunch of applications that wouldn't be possible before due to currently having too high fees. As an example, Manta Network, which launched around December 2023, or rather integrated using Celestia underneath in about December 2023, if I recall. Since then, they've calculated that they've saved almost $2 million in gas fees by using Celestia for data availability instead of Ethereum call data. And that is one protocol in the span of 2 months and change. Now, imagine you scale that across much more used protocols with a larger number of protocols. Maybe you have 1 million rollups, as we like saying, 1 million rollups. And then the gas fee savings become astronomical. Okay, so what else have we seen kind of come out of the launch of Celestia in the first 100 days, or 120-22? So this is a screenshot of L2 Beat as of today, which kind of shows various layer 2 protocols that settle to Ethereum. There's obviously a bunch of layer 2 and rollups and stuff that don't settle to Ethereum. There's a number that are Celestia native, for example, or that are native to other blockchains, such as I guess Solana. I don't know if Solana has any L2s. But as you can see here, the ones kind of highlighted in purple here, which is 8 out of the 40 or 41 that are not currently under review, are using Celestia for data availability, with dozens more on the way. There's like a little tab over here that isn't in the screenshot of upcoming layer 2s, and like a lot of those use Celestia for data availability. Okay. What else have we seen? We've seen the kind of productionization and deployment of things that people have been talking about for a long time, but didn't actually deploy for a long time for various reasons. One of them being kind of the lack of a scalable data availability solution, which kind of, without a scalable data availability solution, there's kind of less value in having a huge amount of execution, because the execution isn't really the bottleneck, it's the cost of data availability. But since then, we've seen the deployment and productionization of layer 3s. So for instance, in the Arbitrum ecosystem, there's Arbitrum Orbit. With Optimism, there's Superchain. And of course, there are also various teams that are kind of still building their layer 3 solutions, kind of work in progress. I wish I had my speaker notes, because I wrote them down in the speaker notes. There's ZK Sync Hyperchains, I think, that they discussed about a few years ago, that's still in progress. There's Starknet, I forget what they call them, but Starknet is also working on layer 3s, layer 3 app chains that settle onto the public Starknet chain. Right, so layer 3s have been, these kind of fractal scaling have been talked about for a long time, but since data availability was the bottleneck and not execution, there wasn't really much need for them. Now that a scalable data availability solution exists, you see things like Arbitrum Orbit, Optimism, Superchain that are coming out into production, and people can spin up a huge number of rollups that all have various nice properties. You can share bridges, share liquidity, share common community values and governance, etc. And this wasn't really a thing that was happening prior to the launch of Celestia. And as it goes without saying that all these things, this is just the first 100 days. And with the launch of additional data availability layers and going into the future, these kinds of things that weren't possible before will only accelerate. Okay, what else? There's also the the kind of launch of RAS, or roll-up as a service providers. For example, here's a screenshot of Conduit, which released publicly, I believe, in February 21st of this year. So this was like barely 2 weeks ago, not even. That basically allows you to deploy a roll-up, choose which stack you want to use, in this case, the OP stack Superchain or Arbitrum Orbit, choose where it settles, so it could be Ethereum, so this will be launching a layer 2, or it could be, for example, Base, so then this will be an L3 on top of the base L2, and of course, choosing your data availability layer. And this kind of thing is like, those 3 layers are exactly the layers of a modular stack that everyone has been talking about, right? There's the execution layer, there's the settlement layer, there's the data availability layer, and you can see it here, it's all in its glory, that you have roll-up as a service providers that will literally allow you to choose which of these stacks you want to use for your roll-up. Click a few buttons, click deploy, and boom, there you go. Your roll-up has been deployed as easily as you could deploy a smart contract, or in this case, possibly even easier. And these kind of things just didn't exist prior to modular blockchains being a thing. right? Prior to this, if you wanted to deploy your own blockchain, you would have to do a substantial amount of work to make modifications, to fork various code that wasn't really made to be forked, and et cetera. And of course, then you would have to bootstrap all the peer-to-peer network yourself, and do all that, bootstrap the validator set, et cetera, just to get a network up and running. Before you even get to like the exciting part of building a community, bringing applications over, et cetera, you'd have to do all this work. In this case, with these roll-up as a service providers, you click a few buttons, and there you go, roll-up deployed. Okay, so that's kind of what we have seen happen in the past 100 days. What's next? We're not done, of course. We need more throughput. You can never have too much throughput. So the goal is at least 1 gigabyte blocks, which will give you somewhere on the order of 100 megabytes per second. Right? So this is another 2 orders of magnitude increase. Right? The launch of Celestia is 2 orders of magnitude over what was existing at the time, and we wanted another 2 orders of magnitude. Right? And this will allow you to have your billion users and your million rollups. In addition, increasing the security of data availability sampling, which is kind of the underpinning of the security underpinning of all these data availability protocols, Celestia, EigenDA, Avail, even Ethereum with dank sharding, right? Some form of data availability sampling is the kind of the underpinning the security. So developing what we've been calling level 5 light node security that includes all the way up to anonymous data availability sampling. And finally, these kind of protocols scale with the number of users that run light nodes. Users contribute to security in a way that they don't in traditional protocols. So you'd like to run a light node anywhere, and for example, even running a light node in your browser. So you can open your phone, you can open your browser, run a light node there, run a light node on any device you want, run a light node with very low resource requirements. And this is something that a lot of protocols don't really kind of emphasize. They say, well, I guess we'll just trust the majority of validators, to be honest. But it's no. You should run a light node. You should accept fraud or validity proofs in order to guarantee with very low resource requirements that the validators are honest. Okay. Last but not least, a call to action, which is build whatever with Celestia underneath. The nice thing about these data availability layers is they're unopinionated. They don't prescribe or restrict what you can build on top of them due to their flexibility, due to them not actually interpreting what executes on top of them. So if you want to have a different settlement layer, if you want to have a different execution layer, even something that doesn't exist today, you can build it, and you can build it with Celestia underneath. Last but not least, a little alpha, some spoilers. We're going to be hosting a modular hackathon called the Infinite Space Bazaar in a couple of weeks. Starts on March 18th. So if any of you are hackathon goers, or if you know hackathon goers, then feel free to check this out. Okay, that's all I have for today. Thank you, everyone.